Ah, d'accord.
C'est dans le Dropbox.
Oui, d'accord.
Voilà. Je peux envoyer déjà les slides, là, les blue sheets.
Il vaut mieux attendre qu'il soit rentré, parce que sinon il va y avoir des trous.
D'accord.
On peut laisser 2 minutes.
Il n'y a pas de micro pour parler? C'est là.
Là-bas, ouais, ils peuvent rester dans le carré.
Ouais.
Donc, alors, comment est-ce qu'on fait?
C'est F5 normalement.
Quand je le regarde dans le web, en fait, ça m'intéresse pas trop de le voir.
Quand je regarde dans le browser,
J'ai pas ces problèmes-là. Ah, ok. Ouais, donc il y a un full size. Moi, il y a un contrôleur aussi.
En menu là. File, normalement tu dois avoir là. Regarde là, tu tapes un là ici.
Ah non, ici.
Ouais. Ah, ça t'ouvre le machin là. Et là, tu as fenêtre. Dans ta fenêtre là, dans fenêtre. Soit là, soit à côté. À côté, tu as un truc en fait. Voilà. Ah, là, affichage. Et là, tu as voilà.
Alors, tu me donnes le petit menu, tu veux voir?
Je te filais déjà ça. Tac, tac, ça marche.
Je crois qu'elle reste sur moi, donc la vidéo, c'est moi qui la prends. Voilà. Intéressant. Voilà. C'est marrant, c'est...
C'est bon?
Celui-là que je vais faisais, c'est change. Ouais, c'est bon. Ouais, c'est ça. Donc, ce qui est marrant, c'est que j'ai plus ma souris. Voilà. En fait, c'est plus le bon écran qui est le principal, mais c'est pas grave. J'aurais préféré garder garder mon écran principal ici. Sinon.
On va voir la centaine.
Oups. Je sais pas, si ça marche pas comme ça, je vais changer.
Je pense qu'à la salle, elle sera vraiment pas suffisante. Voilà. C'est bon là?
Ouais, c'est bon, parce que je garde mon écran ici. Je peux faire mon multiplier.
Je pense que. Allez, on commence en retard. Non, mais il faut laisser l'ordi. Il faut laisser.
Mais je suis sûr, c'est pour ça que je vais le récupérer ici.
Ah, d'accord.
Ouais.
Attends, j'ai fait. Faut que tu cliques là.
Hi, Jeff.
Hi, Jeff. Nice meeting you.
I'm here for the day.
Thank you. Please jump the mic.
Yeah, just say yes.
Yeah, whatever. I mean, it's just, let's see why I could be here.
Congratulations. This is good.
Yeah, I did tell you before, right? Me too.
This is awesome.
Well, thanks for being here.
So we'll be circulating the blue sheets. For the speakers, please note that the square is on my left. So when you come to speak, please stay within the pink square on the floor. C'est quoi notre asymétrico?
Ouais, ça c'est le. Ouais. Attends. Je pense que tu peux pas travailler en même temps si on veut utiliser le clicker. Donc il faut vraiment que tu cliques là. Donc tu cliques là.
Bah, je fais rien.
Hein? Clique là sur l'écran à côté. Il faut cliquer sur.
Là-dessus.
Ouais, voilà. Okay, maybe there are a couple of places just here on the first line, so you can come and we can start.
Je vais faire l'intro. Tu feras le passage de slide du coup.
Ok. Bah, tu tiens. Ça marche.
Ça marche ici. Une photo à prendre là. Une photo à prendre. So this is the low power wide area networking work group forming BOF. Thank you all for being here. So we have 2 hours and Alex and myself, Pascal, will be chairing for today. This is an official IETF meeting, so we are following the best practice. In particular, if you're aware of some IPR in what is being discussed today, please notify the group or let the chair know at the end of the meeting. In any fashion, please review the BCP that are being listed here. So the agenda for today will be a general introduction by the chairs, which should take like 5-10 minutes max to present that. Then we'll be going through 4 technologies, starting with NB-IoT and Suresh presenting. And then we'll do 15.4G and YSUN, that's going to be Bob, and Laura with Alper, and Sigfox with Juan Carlos. Once we're done with this, we'll go through the gap analysis between the needs from those technologies and the actual standards which are available at the IETF. That will be Anna presenting to us. And for the second hour, and Carlos actually will be looking specifically on IPv6. And for the second hour, we'll be going through the classical questions of whether there is work to be done at the IETF, whether this is feasible, and whether that takes a new working group to achieve, because this is a work group forming BOF. And most of that time will be spent looking at the charter. We have a candidate charter that's been elaborated over the mailing list for the last 3 months. So it's rather stable, but we'll go through that and then we'll try to answer those questions about the opportunity to build a working group together. And with this, I will let Alex.
Thanks, Pascal. So welcome everyone. Today we'll be talking about low power wide area networks, and we'll start with a short overview of what we understand are low power wide area networks and the general architecture before diving into the particular technologies. So we start first with low power. So low power, this is we can understand it in 2 ways, either from transmission point of view, where we can transmit only with 25 milliwatts of power during a very limited time, or additionally we can look at the topic as devices that we want to be working for up to 20 years on a single battery. When we talk about wide area, it's actually very high sensitivity. So sensitivity which allows us to go up to 50 kilometers, 15 to 50 kilometers in line of sight communication. And even within urban environments where you can go into the basement and you can have 2 to 3 kilometers of communication. And this is where it gets interesting. So when you combine the two and when you want to build networks out of this, well, there you have quite a lot of questions. How do you build networks out of this, and what is the face of these networks that you're building? So typically you have a star topology. So this is one of the things that is of great interest, and you are going to be quite often having asymmetric links. These combined to the very low throughput and to the huge densities that you can have due to the very wide coverage leads to a lot of questions that we need to address. In addition to this, we have deployments into license-free frequencies and licensed network frequencies. When you're in license-free spectrum, then you need to do a duty cycling, and you have 1% of the time that you need to that you have right to communicate to. So when you take all of these parameters, like you can look at this like some kind of an optimization problem, and you have many constraints. And when you take all of them into account, you can get to one end of the spectrum where you have when you have a throughput of up to 100 bits per second, and you can use it for 1% of your time. And you have payload, which is up to 12 bytes, right? These are things that we have never seen until now. And when you are playing with the different constraints, you can have different types of properties, you know, but then maybe you will not always have 20 years of battery life and so forth. So we'll be playing in all of these things, but still we're in this family of LPWAN networks. And now what we're interested in here is how we are going to bring the IETF ecosystem and the IETF protocols to these types of networks. So what we have today is we have an device on which you have a device application on one side. On the other side, you have some application server and some network application that runs on this application server. You have some radio antennas around it that take the signals and that typically send all this information to an LPWAN gateway. And from here, you have some kind of a tunnel or something that brings this to the application server. So this is what we have today. Now, our goal here is to see how we can bring the IETF ecosystem to this type of networks that are typically built with this type of in this architecture, and how we can, enabling these networks with all these constraints, how we can put the IP stack over them. So bringing IP to the end device and to the network server, and also enabling, of course, going up to the application layer, UDP and co-op. Things that we could look at also are how we can bring some other of the things that we know how to do at the IETF, some as doing AAA or management for the devices or for the management core. So these are things that we can do right now.
And we are switching speakers because apart from what we can do now, there are a number of things which we could consider for the future, not immediately, but as the work progresses within the working group, then we can take new challenges in. And some of the challenges that we could consider for working group would include, for instance, the management of security. How can you make sure that a certain device can only be reached from a certain application and back, allowing some flows but disallowing some attacks on some device, because we all know that we won't maintain those devices the way we maintain the PCs today with the latest level of software. At the same time, we want to ensure mobility to some use cases where the devices are actually inside vehicles or applications like that. And finally, there is a constraint for the IETF that we don't want, by multiplying the number of devices by 1,000 in the internet, to multiply the size of the default free zone by 1,000. So there must be a way to use, I don't know, ULA addresses over overlays, something like that, so that we can get both security, mobility, and addressing that does not leak into the core of the internet. So these are things that the working group could consider. Another thing that the working group could consider is, you all know that LTE and BIoT is based on scheduled operation, so that the devices only wake up when it's time for them to operate. This is not necessarily the case for all technologies. Some technologies still have not developed those capabilities, but we've done that at the IETF. We have 6TiSH. 6TiSH enables to augment the density of devices by having them send one at a time and avoid the halo-eye type of collision. At the same time, 6TiSH enables the devices to listen at the right time so they can stay sleeping the rest of the time, and they save battery. So 6TiSH is good for density, and 6TiSH is good for battery operation. This is all based on scheduling. So there's an opportunity there in taking those type of IETF capabilities onto NB low power wide area network technology. So we see that there are things that we can achieve kind of rapidly, like look at how we do IP, etc. And there is a lot more that we could consider over time, putting additional IETF technologies about those LP1 networks. Okay, and with this, I will let the ball to Suresh. So Antti is not with us, so Suresh has nicely accepted to present for Antti.
Hi, my name is Suresh. I'm presenting from my colleague Antti, who wrote a draft and also did this presentation. So I'm physically here, so I'm doing it for him. And so this one describes like one of the technologies that's being considered for LP1. So this is called NB-IoT, and this is something that's coming out of 3GPP. So if you look at like the 3GPP architecture, like for what they call machine type communication, so like IoT, machine to machine things, there's like two broad categories. So there's like one that's called massive MTC, another that's called critical MTC. So massive MTC is like where the low cost, low energy devices are, and the critical MTC is where like you have stuff like substations, industrial automation, where you need like really high reliability and low latency and so on. So the LPWAN stuff kind of plays in this massive MTC area. So if you look at the numbers, they're like very similar to the other things you are going to hear right after this. So like the idea is to come up with like a cheap device, like around $5 a device, and have like extended coverage. So the 164 dB maximum coupling loss is like how 3GPP denotes coverage. So like this is like the border at which you can actually deliver the service. So if the loss is any higher than this, you cannot actually deliver the service. And again, like a high battery life, like so you'll probably see like 10 years and 20 years, like magic numbers tossed around. So the number is greater than 10 years. Okay. And so the idea of like this thing is to actually go towards operator who have a 3GPP network and try to go towards that. And one of the things that's different about this is going into a license band. Okay. So so if you look at like stuff like Sigfox, like they're targeting mainly towards unlicensed bands, but this is like going towards licensed bands. And there's like 3 different deployment modes. I can describe in a little bit more detail in the next slide. And the bit rates are around 300 bits per second to 200 kilobits per second. So if you look on the right there, there's like 3 kind of different modes of operation. Okay, so one of them is like you have a standalone carrier, like a 200 kilohertz carrier, like just for the NB-IoT stuff. And the second stuff is you put the carrier in a guard band. So like guard band is something, it's like an unused frequency, and you put it in between the bands you use for, let's say, reducing or preventing interference. Okay, so this is like think of it as a white space. And so what happens is you can deploy NB-IoT in a white space kind of thing with the guard band kind of deployment. And the third one is like you can actually deploy in band with like already existing LTE deployment that you have. Okay, and the reason I talk about LTE is like there's a lot of stuff in common other than the radio towards the LTE networks. I can talk about it in a bit. Okay. So as I said before, like the MCL is like 164 dB in here, and like so there's like a bunch of calculations you can actually go and look at. So if you look at there's a draft accompanying this. So if you look at it, you can find more details if you want to look at the details. And the idea is to give like long range coverage, so around 15 kilometers per base station. And like on. So if you look here, that's like the numbers concerning this. It's not like that important for the work here, but if you want to know more about the technology, those are the numbers in there. So it's in the slides. Go look them up. And for the L1 characteristics, so this is like following the template like Pascal and Alex were setting out. And so the modulation scheme, like the highest one supported is like QPSK. And right now it's like designed only to work in licensed bands, but doesn't prevent like in the future that it's going to go into unlicensed or not. Like we're not making any statements on that. And as I said, again, the goal is like a 10-year battery life. And L2 is like a bit more interesting. So PDCP is something called Packet Data Convergence Protocol. It's like one of the protocols in the LTE stack. It sits right below IP. Okay, so that's where like all the segmentation and reassembly of the lower layer frames is going to be done. So we can support like an MTU of 1600 bytes, which is again very different from a lot of the other technologies, which are like severely constrained, right? Like either tens of bytes or hundreds of bytes. So this is like one issue that NB-IoT doesn't have. Okay. And there's also like ongoing work for doing multicast support in here. Like there's like another slide where we talk about ongoing work. And another thing that's kind of different is like since it's targeted towards existing deployments of 3GPP networks, like mainly LTE, like a lot of the stuff comes for free. For example, authentication, right? So we use all the existing mechanisms today. So if you have like a set of SIM credentials and you have like a server that already does it, like you can just piggyback on the same thing. So there's like two kind of mechanisms. So one of the AS stuff, which is where you send your payload stuff, and the NAS stuff, which is like the non-access stratum, where you do all the authentication and security and all those other things. They go through the same ER interface, but then they get pulled out at the radio base station to a side interface where this thing happens. So if you remember like the LoRa case, it's something that's very, very similar, except the names are different, but it's something like a sideways interface between the network gateway and the joint server kind of thing, right? The joint gateway kind of thing. So it's like very, very similar in nature, but it's piggybacking on existing stuff. So we're not like redoing anything for NB-IoT. Yeah. And so one of the things, again, that's probably different is like this, like since we use existing mechanisms in 3GPP, it's going to have like mutual authentication. So there's going to be some kind of mutual authentication provided between the network and the device itself. Okay. And there's like encryption and integrity protection, again, existing stuff. And so this is like the ciphering and the header compression are kind of like put in together into PDCP. So it's like that protocol handles both the pieces. And the key management is also like very similar to what exists today. So there's like a shared secret that's sitting in your SIM and in the authentication side on the server. And there's like a key hierarchy that's defined. So how you take the shared secrets and some kind of random stuff to make a session key and a master session key and so on. And if you look at the system architecture, it looks very similar to what you have in a current mobile phone. Okay, so the backend network is very similar. So the EU TRAN is the part like that's like the radio network that's supporting you. The MME is like the kind of the control plane entity that's branching off. And so what is happening is like the UE kind of can reuse like a lot of the parts of the network, except the pieces you want to put in for handling IoT or optimizing IoT. So, so this is like a summary slide. So one slide, look at it, and you can have like different kind of deployments, in band, out of band, guard band kind of thing. It's got like a lot of coverage, and the technologies are similar to current phones, which is like OFDM on the downlink and SCFDMA on the uplink. And it's like pretty low bandwidth, like around less than 200 kilobits kind of thing, 300 kilobits kind of thing, and about carrier size of about 200 kilohertz sitting in there. And the MTU size is like 1600 bytes. That's kind of the most relevant things for the Lpwan BOF. So that's it from my side. Any questions?
Yeah, thanks, Suresh, for the presentation. Any comments on the relevance to this, what you're expecting from this BOF?
So
in the context of NBA.
I'm presenting for somebody, right? As an AD, I have different expectations than like Antti, right? Like, so Antti wants to like, okay, if I can channel Antti, it's like he wants this to, the whatever Lpwan comes up with, to work with NB-IoT as well, instead of doing something else, right? And as an AD, like I like that the other SDOs, like, you know, I see Jeff in there, like for LoRa, and like, you know, Juan Carlos coming in for Sigfox. Like, it's really good that the other SDOs for potential consumers of this are here and participating. Okay, so at this point, it's just like information sharing, right? Like eventually, I would like to see further engagement from the SDOs.
Thanks.
I'm Lorenzo Evangelista. Is there any place where we can find the specifications for narrowband IoT?
So some
are they available right now?
So you're into digital, right? Did you say into? Okay.
I'm from University of Padua and Patavina Technologies.
Okay, so like a lot of the specs, so there's a draft that accompanies this, which has got more detail. And if you want more than that, we can figure out like a way of getting the stuff. But it's usually like for 3GPP members who get the documents. I think it's very similar to everything you're going to see today. But if you really want the documents, I think we can figure out a way, like probably through liaisons or something, to get like specific documents you want.
Yeah, thank you.
Lionel, do you want to talk about that? Down like this, Lionel, getting to the mic first, and then you're on next.
Yeah, thank you. Yes, for information, they are publicly available on the 3GPP website. So I think we can figure out putting the specification number and so on, but like you can find the specification on the
last published one, right?
Yes.
Like I said, the
Yes.
CRs and everything and all.
or the stable ones.
Right.
And just an additional comment is that you have described so the basic architecture, but along this architecture you have also additional mechanism like to be able to monitor all the UEs and so on that is in line with the scope of CIoT. So it is one view, but you have also multiple spec to be able to do more than what you have described.
Right. So Lionel, just to answer that, this is supposed to be the sub IP view, like relevant just for LPWAN. So like nothing more.
Yeah.
So that's.
It was based on the scheduling approach and how to be able to monitor the UEs and also to be able to support IP mobility, not IP mobility, but mobility management.
Okay, thank you. No.
So Suresh, it's not release 13 this is in, it's targeting 14, is that right?
Yes. Yeah.
Okay.
Yeah, there is like something in 13 for CIoT, but like.
It's just a shell though, right? It's
Yeah.
not the-
Yeah, go.
Yeah, you have one part of the work. So the basic principles are done on already in release 13, and the work is going on in release 14. That is the current release discussed in 3GPP right now.
Okay, thanks. So as I said, there's like a draft to go with this. So feel free to go take a look and send a message, and like Antti will get back to you. Thanks.
Perfect. Thanks, Suresh. And Bob, I think the floor is yours.
Renzo Navas, sorry for the chairs. I can be the JavaScribe if you don't have.
Thank you. Thank you, Renzo.
Gee, it's a full room. Okay, this is me. Okay, I'm not going to be particularly technical on this one, nor did I follow the template particularly, because we're kind of in a different place. As I kind of went through some of the various aspects last night when we had the technical session and in discussions, sort of the realization that, you know, this effort, which is a very important effort, by the way, so I just fully support this, is really somewhat narrower than the domain that's covered by 15.4. 15.4 is a very robust, very broad standard. In fact, some would argue it's too broad, but it's very highly flexible with a very different range of capabilities, among them being low power WAN capabilities, as well as other techniques of achieving the goals of low power WAN, but might not fit into some of the more common architectural agendas. So it also allows for very optimized L1, L2 approaches, and that's really depending on the application. I mean, what we've seen in the deployments over here, 15.4 has been out since 2003, so 13 years now, we've seen a lot of very creative uses and approaches depending on the application, including in-building stuff, industrial IoT, and field area networking. So all these things are fitting kind of in the domain of some of the narrower specifics of what the BOF here is all about. It also supports both structured and ad hoc self-organizing networks. So again, this is why, you know, this whole activity was just somewhat different than perhaps some of the more, I will call, directed approaches to low power WAN. IETF and IEEE 802 have been collaborating for years, which has been a very good collaboration, and is one that's continuing. In fact, it's deepening as we move forward. Consequently, most of the needed network layer elements that may be lacking in some of the other approaches already exist, although work continues. I will point out, though, and this is a conversation I had with Alexander earlier, is there are some specific pieces in 15.4, most notably stuff in 15.4a and in 15.4k, and bits and pieces of 15.4g, where we've got very low data rates that wind up with almost identical issues or problems of, you know, I don't like the word problem, but issues that we might see with some of the other technologies under consideration here. So as you listen to the other two presentations after this one, listen to their issues about the low data rate and stuff like that, because what they're going to put forward in terms of needs and stuff like that are going to be very similar to the kinds of things we're going to see. The Wi-Sun Alliance. Not all of you may be familiar with what this organization is all about, so I did really want to just give some very quick bullets on that. We develop network profiles. In other words, standards have lots of options in them, and unless you specify what options you're going to use, interoperability is sort of like impossible. We focus particularly on the stuff in IEEE 802 and IETF, although we do occasionally pull in stuff from other recognized standards development organizations. We also, and I think this is the key for why we exist, we're like a Wi-Fi alliance in this regard. We develop the supporting test and certification programs. So manufacturers who are building this stuff can get the stuff tested, and if it passes the test, it gets a mark. If somebody's issuing RFQs, they can say, I want this capability in any products that are supplied to that RFQ. We do not develop standards or technology, so we're not in that business. We really are only taking from stuff that exists through SDOs. In terms of the profiles, we currently have a few that are completed with test and certification programs. We do have a field area networking profile, and I'll show that on the next slide. We have a profile for TEPCO Route B in Japan. I won't go into details of what that is. Some of you know. Home area networking profile is also one of these pieces. So you can see we are kind of covering the waterfront of both inside and outside. The Route B and the HAN are examples of point-to-point and point-to-multipoint, and they're using 6LoWPAN and PANA. And the network FAN profile is an ad hoc self-organizing network. So again, little bits and pieces depending on what the application is that we're trying to solve. Currently projecting over 60 million Route B and HAN installed devices in Japan by 2020. So that's just kind of the tip of the iceberg of stuff that's happening around. I'm not going to go into this one in great detail. When you can download this presentation, this is the OSI of the stack. You can see all the elements here that we've pulled out of both IEEE 802 and IETF. Not much more needs to be said about that. And then why are we here? I think I've kind of said that little bits and pieces along the way, but let me reinforce that. We do serve the LPWAN space, among others. We consider this to be very important, and our interest in this particular area is awareness. In the event that changes are needed, I think it's very important that we're part of this process so that we can pull those changes in to profiles and build the corresponding test and certification program changes. We do very much want a consistent approach. So things that we're going to pull into 15.4, we want to make sure that's the same kind of stuff that we're pulling into a Sigfox or a LoRa or an NB-IoT. We feel, because we've been out there for a while, we have some relevant experience to share. So we're quite willing to do that. And then these solutions are going to wind up in the market together. So one key piece is coexistence. I mean, even if we don't talk to each other, we got to coexist. So that's a very important part as we consider stuff here, that we're doing things that are complementary and that foster coexistence. But likely too, there are going to be circumstances where we want to interoperate. So I think that's also an important aspect, which is why we're here. Just as an example, because we already use IP, we can connect to Wi-Fi and wired networks, Ether networks, over routers. So that's something I think we can. You see how we develop that more broadly, and that's. I guess that brings us to Jeff after any questions.
Srigundavalli. So I have the same question as what I asked Suresh. Any specific technical requirements that you have identified, that what you need from IETF?
Okay, somebody translate that for me.
Specific technical requirements. Do you have any specific technical requirements?
I'm not going to list any now, but if you listen carefully to what's going to get said in the next two presentations, a lot of those requirements would be very similar, would be ones I would characterize for those instances in 15.4, which kind of fit this category of the low data rate L1s.
Okay, thanks.
I think Sabir was ahead of you, Don.
Okay. No problem. So Subir Das from SCS, thanks. Bob, thanks for presentation. I would just like to add one thing that, there is another organization user of the 802.15.4 technologies similar to what it's supported by Zigbee called Jupyter Mesh. And that's exactly using the same thing. And we do with IETF, for example, with 6LoW, we have a couple of drafts which are actually helping to take the IETF IP technology and go to the marketplace.
Yep.
So, and to answer that sweet question is that it's important that not a lot of differences, as Bob mentioned that for the IP requirement we reuse as much as possible, and if there are certain changes are required, we just go to the corresponding working group and propose the draft, and that's the way it works. And 802.15.4 technology is widely used today.
Yeah, I forgot to mention, but we're working on another project in 15 right now called 15.12, and I think what goes into that is going to have relevance back to this group too. So that's a sort of watch this space. Don?
So Don Sturck, Silver Spring Networks. I actually co-chair the Wi-Sun fan work with Paul Duffy from Cisco. And there's a couple of deviations we had to make in neighbor discovery to make our stuff work that I think actually belong as a amendment to 6775. And I think the other thing that we should probably talk about is the address lifetimes. Because if you've heard from devices some other way, there's no reason why you have to go through this whole activity in neighbor discovery to go send all these messages again in 18 hours.
Good point. Anything else? All right.
Okay, so thanks so much, Bob. That was great. And Alper, yes, the floor is yours.
Hello, everyone. My name is Alper again. I am the LoRa Alliance Strategy Committee Vice Chair. So I will give a brief introduction to LoRa and highlight the aspects that would be interesting to this community. Excuse me. So LoRa stands for long range in the radio sense. It operates in a sub-gigahertz ISM band, which means it's operating in the unlicensed frequency. And the data rates range between 300 bits per second and 50 kilobits per second. And as for the range, it can go beyond 10 kilometers. So in terms of the payload size, it's a variable between 11 bytes and 242 bytes. Depending on the radio conditions, the MTU changes. As for the battery consumption, more than 10 years operation is expected, so the technology is designed accordingly. It supports bidirectional unicast messaging and also multicast message from the network to the devices. It has a feature called adaptive data rate. So the network and the device can negotiate the transmission power and the data rate according to the network conditions in order to utilize the network at maximum capacity. And the solution we have in the LoRa Alliance, it does already support mobility. There are various types of handovers it supports. So this is an illustration of the adaptive data rate. As the device gets closer to the gateway, it can increase the data rate. And as it drifts away from the base station, it reduces the data rate in order to stay within the limits of the transmission power. And as it reduces the data rate, it also has to reduce the MTU size, because there are limits on the duty cycle and there are limits on the dwell time. So that requires the device to be transmitting less packets over the air. So that's why there is a change in the MTU as the device gets away from the base station. And there's a dynamic negotiation between the device and the network in order to adjust those parameters. We accommodate 3 different types of devices in the LoRa technology. Class A is the device that's used for sensors. In most of the time, the device sleeps. Only when it needs to transmit, it wakes up and makes a transmission. And that's the only chance, that's the only time the network can transmit something back. So the downlink is possible only immediately after an uplink transmission. And that's how we can conserve energy. In Class B, there is a schedule where the device wakes up and listens to the channel. So by the network knowing that schedule, the network can transmit downlink messages. So if you're building an actuator, you cannot do that with class A because you cannot really send asynchronous messages down to the device. You have to have at least class B or class C where the device can receive any packet anytime. So depending on the use case and the battery or the power source, you have to choose your device class accordingly. So here's an example where a class A device sends a packet to the network, and then the network has two chances of transmitting a downlink packet. There's an RX slot 1 and RX slot 2, and the schedule is known to both the network and the device. So if the device doesn't receive a downlink packet at slot 1, then it will try to receive it at slot 2. If it misses both, then it cannot get the packet down. Whether the first packet was received or not, the network does transmit the second one at a different data rate and at a different frequency to increase the chance of reception in the downlink side. And if we look at the architecture, it's pretty like what you would expect. There's an end device, the terminal, that has radio connectivity to one or multiple radio gateways. So what you would call base station in other architectures, we call radio gateway. And those radio gateways are aggregated under a network server. That's where the LoRa MAC layer terminates. We have a distinct join server, which is in charge of authentication and authorization of the devices joining the network. And then we have an application server that's the endpoint of the device communication. We support star topology with point-to-point links. The MAC layer is called LoRaWAN, and it's a compressed version of 802.15.4. It's like heavily compressed version. And the release 1.0 is publicly available. You can download it from the LoRa Alliance website. Devices are identified by 64-bit identifiers, and the addresses are 32-bit addresses, which are dynamically assigned by the network. With the LoRa, you can support both public and private deployments, meaning that you can be an operator and have like a citywide coverage or nationwide coverage, or you can be an enterprise, or you can even deploy it at home to use it for your own private needs. Right now, the LoRa Alliance is working on release 1.1, which is slated to be released at the last quarter of this year. And in that release, we would have the backend interfaces defined, not only the radio over the air side, but also the backend interfaces between the application server, network server, and join server. And we would be using those backend interfaces specifically for roaming support. And on the security side, we are also splitting, well, we are going to support two distinct keys, one for the network layer and one for the application layer. There are further details, but I think at this level of discussion, those are the most relevant things. And this is how the stack looks like. There's a file layer and MAC layer, and various applications would be riding on top of the MAC layer. So if you're building a Zigbee application using LoRa, you would have a compressed version of your Zigbee stack sitting on the MAC layer. And there are other protocol stacks possible and available and being used in the industry. And you can also have your own proprietary application stack. What we don't have right now is a standard way of carrying a CoAP and IPv6. So there are proprietary implementations of these protocols on LoRa. And this is an item that we think, if and when this group delivers, it can be used along the line of all these application layers sitting above the MAC layer. As for the security, we have a per device application key and network key. These are AES 128 keys. Using those keys, we perform mutual endpoint authentication via a joint procedure using AES CMAC, specifically RFC 4493. And then we can provide data origin authentication, integrity protection, and replay protection using the same CMAC. And we also provide encryption of the MAC commands over the air. And we also provide end-to-end encryption. using IEEE 802.15.4. We have a proper key hierarchy with root keys, and out of root keys we generate session keys, and we can also roll the session keys through re-authentication or rejoin procedure. And where is this whole activity happening? In the LoRa Alliance. It's an alliance working on standardization and writing specification for over-the-air interface, the MAC layer, and also the backend interfaces. And another objective of the alliance is to create an ecosystem, full ecosystem to support this technology. This alliance was founded in March 2015, not too long ago. Nevertheless, we have a big membership, 359 members, covering anything between chipset, module device, infrastructure, and also the operators. We have the chair of the alliance here, Jeff Mulligan, and also a number of members are present here. There's been 16 announced nationwide and operator deployments covering anything between cities and the whole countries. And there are more than 56 ongoing trials. And in the LoRa Alliance, we have 4 committees, including strategy, technical, certification, and marketing, to provide not only the specifications, but also the ecosystem to move this forward. And that's all I have to say in a nutshell.
Thank you, Alper. And we thank all the members of the LoRa Alliance who are present today, because we know you have to travel very quickly to Munich tonight. And so thank you so much for being here.
Sure.
And
Don Strick, Silver Spring Network. So a couple questions. Do you envision the end device to the network server being in scope for things that you want IETF to help you work on? And secondly, if you do, would you help distill down the requirements? Because I've read the spec and I found it really complex in terms of all the changes in data rates, et cetera. Would you be able to distill it down to some set of?
Yes, we have a plan on that. We can definitely generate a draft to give a gist of it, but as you would ask more questions, it'll converge to the spec that we already have. So we would have to figure out where to stop. But we will start on that, yes.
Okay.
Yeah, and better than that, if you have any questions, feel free to reach to us. You know.
Did you say the end device to network server that's in scope for something you want IETF to work on, or no?
No. Okay, yeah, that question I didn't fully get that. We already have a MAC layer. And I don't think IETF would be working on a MAC layer here. But for supporting IPv6 and also CoAP, that's where we think what this group would deliver would be useful to the LoRa Alliance.
Perfect.
Thank you.
Thanks very much, Alper. So
I have one question for Alper.
Okay.
Samita Chakrabarti, 6LoW Working Group Co-Chair. So I understand, looking at some of the type of devices, some of the requirements, those are constrained devices. And I'm pretty sure you're familiar with the 6LoW Working Group and IPv6 for constrained node devices that can run off multiple constrained node layer 2 networks. So have you considered those? And maybe they don't fit in as exactly as it is, but there is something 6LoW Working Group can help with. Of course, we are Lpwan is probably, if it is formed, it will bring some of the work there, but just asking.
Yeah.
As it is now, what are your evaluations?
Right. Yeah, I think this is something we would have to discuss at the end, like in respect to all the existing working groups and work, what exactly needs to be, what is left to be done. We are under the impression that the requirements coming from LoRa is even more constraining than the present requirements which led to the design of the existing protocols. So, but if you guys, this is what we're thinking, but we can debate that and then find a common ground. Yeah.
That after
Sure.
the end of the session.
Mm-hmm.
Okay.
I may add, Samita, that even if the architecture and functionalities are being debated here, it is almost certain that some of the work which has to be done based on what appears here will be pushed as to other working groups such as 6LoW, right? I mean, 6TiSH has been working exactly like that. A lot of the work that is happening now at 6LoW was actually kind of induced by work at 6-dish, right? So I expect something very similar here.
I think
Okay, so hi everyone, my name is Juan Carlos Zúñiga and I'm here to talk about the Sigfox technology. I just want to take 1 minute to explain you what Sigfox is, because I know a lot of people ask questions, and it's true, it's complicated. It's a different type of solution, quite unique actually. So some people say, what are you? Is it that you are a service provider? Is it that you are a network operator? Is it that you are in a specification? Is it that you are a manufacturer? Is it that you actually do devices? You have a certification program? You have a non-for-profit organization and doing cool things in Antarctica and rhinos in Africa? So the answer is a bit of everything, but we are mainly an IoT service provider. So that's the key thing to understand. We do work with a certification program, partnership program, enabling this ecosystem with other technologies. And we have a piece of everything that would look like an alliance, like manufacturing, but in fact, we do license our technology free, so we don't make money out of that. What we concentrate is on the subscription part of it. So we have, as you will see, as part of the partnership program, we collaborate with companies like TI, STM, NXP, and other device manufacturers, and we make sure that we make an ecosystem that reduces the cost as much as possible, because that's the end goal, to provide a system that is as low cost as possible. However, well, I'm here to talk about the actual technology. So we do have a specification out there that is used to connect to the network, and that's exactly what I'm going to talk about, because we need to understand the technical details in the scope here of LP1. So for the architecture, how the network works, it's central, it's global-based LPA gateway with a cloud service center and several radio gateway base stations in the world. So the end device application is transparent to the network. And something key to understand here is the fact that it's central and it's global, cloud-based. Base stations are deployed in several countries, but they connect to a single core network. So there's no need for roaming. There's no need for several subscription models. It's a single subscription model for all devices. The end-to-end device identification and localization is based on a unique global ID, 32 bits. And as I mentioned, it's central, so there's no requirement for roaming. On the uplink, well, similar to what was discussed before, we operate on the ISM band, so sub 1 gigahertz. These are the characteristics, and there's also a draft describing all these in details. Well, you have some of them. As you can see, it's pretty similar. In our case, what we have is, it's called ultra narrow band. So it's a different type of PHY, but it's compliant to the ISM regulations. And as a result, well, we have a smaller channelization mask, a smaller baud rate, different modulation schemes, and so on, different link budget. And of course, something key to understand in our case, as you will see later on, is that we work in an asynchronous way. So something very similar to what Alper described as a Class A type of device. For the downlink, a little bit different characteristics. Again, constrained by the regulations. We have a 1%, as you saw before, duty cycle in the uplink, 10% in the downlink. But when we have base stations that have thousands of devices, 10% is not quite much. So this, as a result, gives a highly unbalanced link that we have to cope with and keep in mind when we design application protocols. For the characteristics, something a little more interesting for us here in the IETF. So the frame, we have this framing that it's different in the uplink and downlink, again, to accommodate the different regulations. So the uplink, it's of course optimized for uplink. So then the network is optimized for sensors. We can also work on actuators, but it's optimized for uplink communications. And we have a payload that goes from 0 to 96 bits. And the downlink is 0 to 64. And again, this is asynchronous. For the fragmentation and encryption, we don't touch. We assume that it's up to the application. We have several applications working on us, but for us, it's transparent 100%. So it's really up to the application provider to do work on fragmentation and encryption, depending on the specific needs of the solution. As I mentioned, the unbalanced channels, And the security, well, for the layer 2 security, we do have message authentication and a unique device ID that are basically with the message authentication code, we can recognize and authenticate the device, and this happens in every message. For the network deployment and the targeted apps, that's pretty much the same ones that we are going to talk about. So right now we are working on medical systems, sensors for waste bin collection, park meter detectors, security in the home, like smoke detectors and so on, anemometers. There's currently a number of countries that are already covered, with some more being added very quickly. So the list is slightly different from what we see in the draft because 2 more countries got added since I wrote the draft, Mexico and Singapore. So for the coverage and the number of devices is 1.3 million square kilometers with 340 million people. The cell size is roughly up to 50 kilometers. And as I mentioned, there are several device applications, asset tracking, smart cities, home safety. But if you click on the partner at sigfox.com link, you will see all the current ones that are existing, and more are added as people basically implement. Expected battery lifetime 10 to 15 years. So that's pretty much it. So I don't know, does anybody have any questions?
Shri Gundavali. Thanks, Juan Carlos. So one question I have is like, are the protocol messages and the formats, are they open? Like essentially, I understand that there's a device ID, at least that information is there. But on the north side, essentially, after the gateway, you said there's essentially a service center, right? I assume there's some function sitting there, right? We call it a network server or whatever. But those interworking details between the device and that function, will it be open, or is that?
So first of all, the good point, I forgot to mention that we do participate in ETSI LTN. So there's the TG28 group in ETSI, and it's working on basically publishing the specification. So there you will have the full spec. In the draft, what I included is a subset, what I thought it was relevant for IETF, but we would be open to add more details if something is needed. So that is the protocol that communicates the radio network to the device. In the ETSI LTN, there will also be a specification about the architecture and other interfaces, but at the moment, I'm not sure if those interfaces are going to be described in ETSI or not.
Okay, thanks.
Downstream. So the interface between the end device and the radio gateway, I'm assuming that's just Sigfox, and IETF doesn't really have anything to do with it, and you're just looking for help out the radio gateway and outward, right?
Yeah. So that interface is basically this at layer 2, and the payload for us is transparent. So anything can happen there, and I think for us it makes sense to work with IETF and define something that goes in that payload that enables more IP applications out there, similar to what LoRa or any other 802.15.4 and NB-IoT would like to do.
No, the second question I have is you don't have any roaming requirements because your devices are not mobile, right? That's the assumption, is they're fixed and they don't move.
It's nomadic. We don't have roaming requirements because you connect always to the same network wherever you are in the world. So mobility, not in the sense of actual movements, but in the sense of handing over and associating to the new network and to a new attachment and so on. We don't have that requirement.
Can a device move to another base station? That's maybe, or another gateway? That's what I was asking.
A device can move to any country, yeah, wherever you have the same frequency. So yes, and that's for instance, one of the use cases is to have tracking systems across Europe for trucks that move around and use the Sigfox network across Europe, because it doesn't matter where they are.
So a question related to authentication. So what's the assumption about the authentication, access security, and what kind of credentials does the device have?
So between the message authentication code and the device ID?
I mean, that's a code. I mean, what kind of access, like EAP, for the access authentication?
Okay, so the keys are pre-provisioned in the device. So you combine the key with the device ID and the message authentication code, and then you can associate. Yes.
No EAP.
No. So it has to be, the keys have to be pre-provisioned.
Gabriel Montenegro. I have a question. I guess it's maybe for all the unlicensed Spectrum users. So I guess you are one of those.
Yeah.
I thought Wyson was another, and I think Laura is another. So in general, what are you guys doing to solve the coexistence problem? Because at one point, both, 2 or 3 of these completely different networks with different network access mechanisms are going to be using the exact same channels.
Yeah.
Have you guys coordinated anything? Do you impose something like listen before talk, or how do you solve that?
So my understanding is there's a regulatory requirements for working in the ASN band, and you have to comply to them. So if you have a narrow band, your ultra narrow band solution, that's the 1% duty cycle, maximum power transmission time, and so on that you have to respect. And there's different requirements for spectrum and other type of requirement. And similar to what Wi-Fi does, for instance, Wi-Fi, coexists with
That's why
microwave
I asked the
ovens.
question, because
So-
Wi-Fi does something, but there are other network technologies using the same channels as Wi-Fi.
Correct.
That are not very friendly to Wi-Fi. That problem exists today for Wi-Fi.
Yeah.
So
And-
I'm
and the
wondering,
microwave
are you
ov-
going to be facing the exact same problem that
We-
exists
we-
for Wi-Fi?
I personally don't foresee that, because we are working in a similar type of environment. It's in your case, for instance, if we talk about, I don't know if you are referring to Wi-Fi against the new 3GPP LTE or
And
microwave,
LTU and all those, yeah.
because
Yeah,
microwave also has a lot
different LTE variants.
Yeah,
It's one example.
so that has to play in the regulatory domain. So and basically what right now is the fair rule is, if you comply to this certification programs, you should be fine.
And this takes care of it throughout the entire
coexist.
world.
Yeah.
No, the rules. The rules.
Exactly, that's why because it's something that's not solved.
As a matter of fact, you have 2 areas. You have the European areas with.
Please go to the mic.
Do you want to go to the mic?
Please. And please announce your name.
This is for people listening to the stream.
Sorry, it's the first time I'm here in this committee. So I'm Benoit Ponsard from Sigfox, and just want to comment. Here we are deploying systems in Europe, and we are fully compliant with the CEPT regulation. So it's enough to share the bandwidths, because there are mitigation techniques in Europe with the duty cycle, maximum time over the air, and maximum transmit power, and it's enough to share the bandwidth, and we can cope with the regulation. In the US, you have equivalent regulation based on the FCC Part 15, but the principle apply also for Sigfox.
Thanks.
Patrick Betterval, Cisco. My question is back to the roaming aspect. If I want to deploy my own service, if I want to be an operator or service provider using Sigfox technology, how can we address 2 different networks? The Sigfox one with the cloud and the Mr. X service provider network.
So let me understand. You say if you want to be a service provider?
Yeah, you mentioned that you have no mobility problem or roaming problem because everything is connected to a single cloud.
Correct.
Okay. Now, if I want to deploy my own cloud and to deploy the same service, how does it work with the Sigfox technology?
So
do you have some service provider ID in the frame, or?
No, we have. We would need to go one level deeper in the details. So we do partner with IoT cloud providers or solution providers, but that is at the solution level. So we provide the connectivity, and then they can add on top of that, added value for data collection, manipulation of the data, and presentation to the user, and so on. So from that point of view, if they are the ones providing the service to the end user, we provide the connectivity, and they provide the rest of the solutions. So that's how we partner with users.
We have to go through Sigfox company to offer the connectivity using this technology.
Yes.
Okay.
Eric Veng, Cisco. Quick questions. I see device ID 22 bits.
Yep.
So is it assumed that each and every device has got a unique ID? So
Correct.
we are limited to 4 billion devices?
Yes.
Wow, okay.
Okay. Thank you very much. And with this, we end the presentation from the baseline technologies. And with this, I'd like to invite Anna here. And just to say that this was actually one of the goals for this BOF today. It was to have a presentation of overview of all these technologies that have some radically new ideas behind them, and that actually bring a lot of new people here. And this is, I think, also one of very, very good step in the right direction. And we already had 2 drafts that actually outline the Sigfox technology, the way it works. You have the technical draft that it's out there. You have the NB-IoT draft that is also out there. So I think that we are really very happy with this. So Anna can tell us a little bit more about the gap analysis based on these technologies and bringing IP to them.
Thank you. Hello. Okay. Okay, my name is Anna. I work at Clio. The goal of my presentation will be to show you the requirements of these technologies and see how the actual working groups at the IETF could manage these problems, or what will be, or what should be done in these working groups, and what should be done in anywhere else. Then, as we have seen for presentation, I just want to give a quickly survey of what they have already said. The most important characteristic of the Lpwan technologies is that they have no IP capabilities. They are asymmetric. They have a small message size. They need to have energy consumption power. And the most, perhaps one of the most difference between what we have done in IETF since many years ago is that we are changing the scale. We are not working in seconds. We are sending that bytes per day. Then we are not sending bytes per second. And that's perhaps one of the most important things we have to take care when we define the new solution for these technologies. Another thing that we have seen in the last hour is that these technologies has a similar architecture, but the difference is the name they give to the different components. Then I summarize the architecture with different colors, with the name of the different technologies. Then we have in green at left side the device, the sensors, and the name that each technology gives to this device. The end device for LoRaWAN, user equipment for NB-IoT, and endpoint for Sigfox. And then they all has a gateway or a station, a base station, or a node B to connect between the endpoint and the base station, for example, for Sigfox. All of these technologies also has a server, a network server, and a registration for authority, and all of them has this application server. Then we have 4 technologies with different names with the same architecture. We have to agree on how we are going to specify each of these components. Then the next part of my presentation will be what does the IETF bring to these technologies? First will be the reachability. IP connectivity will bring the global communication between these devices. We can use or adapt actual protocols. We don't need to invent again the new things. IETF will bring a strong security, scalability, reliability, interoperability, and of course, as we introduce IP, we introduce a new problem that is overhead, and then we need to solve this overhead for these new technologies. Then we need a header compression. Then I go for the IPv6 technology. I will not explain all the IPv6 problem because the next presentation will talk about configuration. I only explain the overhead problem. Then IPv6 introduce 40 bytes of overhead that is much more larger than an Lpwan packet. Then there are some solutions already developed in IETF. The first one could be Lpwan. Lpwan was developed to run in the constrained node, but the solution is not enough. We think that it's not enough for the Lp1 technologies. First, because in the best compression, when I use local link addresses, I can only go through 6 bytes. Then it's 10% of the LoRaWAN frame, or the half of the SIGFOX message. And if I use global addresses, then I have 37 bytes. Then it's almost the LoRaWAN frame and 3 SIGFOX packets. As I told you some time ago, then we need to think that we are sending message per day. Then if I can only send 100 messages per day, and 3 of them will be used for header, then I have a problem with Lpwan. Lpwan, no, is this one? Lpwan has also been used in Syslo working group to be adapted for some other technologies, constrained technologies. But these constrained technologies are different from the Lp1 technologies because of this throughput and the asymmetric lines. There is also the ROC solution for the overhead compression, but the ROC solution was used to be defined for the streaming multimedia flows. Then the characteristic of these flows are quite different from the ones we have in Lp1 technologies. There we have bytes per second. We have a flow. And we don't have a flow in Lp1. We can of course adapt this protocol, but it will take a lot of efforts to converge to something that could work in Lp1 technologies. And of course, we have packets that are not routable in ROC, then we cannot go far away from the gateway. And it's a very complex protocol. Then you have profiles, operation modes, compression, parameters, different header formats, a lot of information to read and understand. And the next working group I will also study was the 6-ish. Then we can adapt to the Lp1. We can adapt 6-ish synchronization to the Lp1 technologies. Then this is not so far from what we want to do. For the routing, then as you have seen, they have the star topology. Then for the moment, or in this first stage, we don't need routing protocols. This doesn't mean that we are not going to use it, perhaps one day. In the core working group, then we see that we need to adapt the co-op solution for the duty cycle, the throughput, and of course, again, the overhead of the CoAP protocol. We have 14 or between 14 and 20 bytes of overhead. Again, it's very big from the LP1 technologies message. And the most important perhaps is to see where we can put all these solutions together, because we can work with SysTish, we can work with Syslow, but where we can put this architecture together and see what is missing or what we need to work more to put a solution for these technologies. Thank you.
Thank you, Anna. Yeah, questions?
Hello. Gabriel Montenegro. Did you say the IPv6 header in 6LoWPAN was 6 bytes?
Yes.
So I know that the original RFC 4944, the common header was reduced to 2 bytes. That might have changed subsequently, but I mean, 2 bytes.
Yes, because I have IPv6 plus UDP.
Oh, so it's IPv6 and UDP.
Yes.
Ah.
Yes, yes.
So in your slides, you had a requirement that says global reachability. What does that mean exactly?
Global reachability. About global reachability, what does that mean?
That one, yes. Global connectivity.
Reachability?
Does
The first
one? But today you can, these devices, you can reach them globally by accessing an API, which is on IP. Are you talking about putting that reachability all the way to the device, or?
May I respond to this one?
Sure.
I think that this is related to the slide I presented early in the architecture, saying with IP, you could get a device reachable wherever it is in the world. Doesn't mean that we want any other device to reach this particular device, right? I mean, part of the work of putting IP there is to make sure that this device is protected from being accessed by any rogue in the internet. But at the same time, we want to be able to deploy the device wherever we like in the internet. So I think that's what is meant by getting global reachability, but only by the device that we want to reach this particular sensor.
So in the architecture, you're planning to build in a restriction by default that only allows a central, a certain set of devices to talk to each other, not everybody to everybody like that.
We'll certainly define how that can be done, at least one way of how that can be done, probably using overlays or things like that.
Okay.
So as to isolate the communication between the cloud and device from the rest of the internet, but leverage the internet to get between the cloud and the device. Yes, and mobility and all those things. I mean, that's what I try to illustrate with these slides with those tunnels.
Okay, thank you.
Hi, Vince Park. I guess I just wanted to ask a clarification. So I think this is good and helpful, but in some of the cases, I would assume that some of those restrictions might be for one particular air interface versus another. So the one that stuck in my mind, for example, was when you mentioned no layer 2 ACK. I think in NB-IoT there is, right? Is that correct?
Yeah.
Okay, thank you.
No, what, sorry? I didn't hear no what.
Oh, if I may jump in. Yes, we have 4 technology, and we probably will never do anything which is exactly needed in the same way by all 4 technologies, right? So we can expect that we'll do this because this technology and maybe that technology need it. And we may do something else for other technologies, like 15.4 already has 6LoWPAN working. They may not be interested in our new compression, or maybe in 15.4K they would, and they would not be in 15.4G, right?
Okay, so maybe last question for Anna, and then we move on to the.
Yeah, thank you, Lionel Moore. Just one question, additional question. It was about the second item. Just in one of the slides was a strong security, and in the comparison on the groups within IETF and what they could provide to LP1. There is nothing regarding security. So I was wondering what was the actual gap analysis on this.
But I mean that we can use what already done and adapt it and see what is missing. I'm not trying to say that we are going to create something new. We need to see if what we have already done is adapted what we need.
So it's something to do, to analyze, to see if there is something to, or the assumption is that everything already done, for instance, in ACE and so on, will be applicable to this one, or it is something to analyze to see if something is missing or should be adapted.
I think on a case by case, we need to see if something is needed, or probably the technology will come to us and say, oh, we cover this general case, but we've got this particular case where we think we need additional security of some form, like we need a more plug and play, non-provision, I don't know, ANIMA type of technology for this particular use case. Can we adapt something from the IETF? And if by chance, we've worked at, 6-dish security or something based on ANIMA or something which enables zero touch or single touch, which applies there, then the IETF will help this happen.
And yeah, please, Jeff, last.
Jeff Mulligan. So Pascal, I'm just trying to understand, the gap analysis isn't done. This is a laundry list of gaps that you'd then like each of the various technologies to help answer.
Is it finished?
No, I think it's not finished because we were waiting to see which technologies we are going to study in order to see which
and who
protocol
better
we can
to
adapt.
answer than the people who develop Sigfox or LoRa or whatever,
Yeah.
to answer the question about strong security or whatever, or how that's being done.
No, I think it's not
Hopefully,
finished.
The alliances and the groups will answer these questions. Okay.
So Jeff, like Suresh Krishnan. So one of the comments I gave to the people working on the authentication stuff is that try to figure out like what exactly is needed and try to find a set of things that is required for multiple of these technologies and then try to work back from there. Instead of saying, okay, let's do a radius stuff for LoRa and figure out like from Alper that if you're using JSON with HTTP, right? And so the idea is to figure out the set of like information elements that need to go on there and the requirements for this and then start working back from there. And that would be part of the gap analysis, see if like a set of IETF protocols can support that or not.
Sure. Thanks very much. Thanks, Anna and Carlos, please. So as I said in the beginning, Anna, her draft is maybe 13 pages, so you can go and read it here, a really short overview. And Carlos also, he has put a special attention to IPv6 applicability. So this is why we split the two presentations. So please. Yeah, well, we must move on. Okay. So it's okay. Thanks. Yeah, you can just move on with the.
Okay, thanks. My name is Carlos Gomez, and I'm going to present a quick overview of this draft entitled Analysis of IPv6 over LP1, Design Space and Challenges. And my co-authors are Josep Paradells, also from UPC IITUCAT like me, and John Crowcroft from the University of Cambridge. So the motivation for this draft is that we, as has been said already, we want to connect LP1 networks and devices to the internet by running IPv6 over on these devices. Traditionally, as Anna has introduced before, 6LoWPAN has been used for enabling IPv6 over constrained node networks. However, some LP1 technologies or setups are even more constrained than what are the typical characteristics of 6LoWPAN. So for instance, some of the LP1 technologies lack layer 2 fragmentation support. As we've seen before, there's a maximum payload size, sometimes one order of magnitude below the one in 6LoWPAN. The bit rate can be several orders below, and critically important, there are further message rate limitations due to, for example, regulatory constraints on the duty cycle. So LP1s really represent a challenge for 6LoWPAN. So in this document, on one hand, we perform an analysis of the applicability of 6LoWPAN to enable IPv6 over LP1, and also a subset of the document is actually could be useful as a guideline for possible future IPv6 over full LP1 technologies. So some of the aspects that might be considered are, for instance, related with the protocol stack. If there are several options as the lower layers, we could ask ourselves, okay, which lower layer should interface with the adaptation layer? And criteria to take into consideration include things like the ability of enabling a link, whether there is fragmentation support or not, and capabilities of multiplexing upper layer protocols. About the network topology and the subnet model, typically LP1 networks, as it has been said already, follow the star topology. So for instance, the document recommends the use of the multi-link subnet model, where the whole LP1 corresponds to one subnet for the simplicity of this model, which is also used typically in 6LoWPAN. With regard to address auto-configuration, traditionally the interface identifiers have been derived from layer 2 addresses in 6LoWPAN. However, recently there's been some guidance expressing privacy concerns, so that the idea is that the recommendation for LP1 would be, okay, devices should not embed their link layer address in the IID by default. So if we want to enable IPv6 over these technologies, in some cases, in all cases, we need fragmentation, and we need to satisfy the IPv6 MTU requirement. So some technologies already support fragmentation at layer 2. Otherwise, fragmentation has to be supported at the adaptation layer. So we could consider, okay, there's 6LoWPAN fragmentation functionality available. Is it suitable for LP1? If we do some analysis here, we find that 6LoWPAN fragmentation represents very high overhead for LP1. And on the other hand, for instance, it only supports maximum layer 2 payload size of at least 13 bytes, which doesn't work with some of the technologies that we are considering here. So this has motivated the development of some optimized proposals, such as the one shown on the slide. Another very important component in the suite of 6LoWPAN specifications is neighbor discovery, which is defined in RFC 6775. Compared with the classic neighbor discovery, provides several improvements, such as host-initiated interactions, multicast-based host address resolution being replaced by ARO mechanism, and so on. So we could ask ourselves, okay, is this suitable for LP1? So one first consideration is that the behavior of neighbor discovery is tunable through the parameters which regulate how often we have the RSRA or NSNA exchanges. Actually, there's been before a comment from Don in this regard. It would seem like it's possible to set most of these parameters to high values. However, for instance, the 18-hour value for the default router lifetime for some technologies or some configurations might still be something actually low. And on the other hand, if we take into consideration the sizes of the main neighbor discovery messages, the conclusion might be, okay, maybe if we had some not so challenged LP1 setups, meaning those with some maximum payload size, at least of 60 bytes or more, and if possible, some duty cycle free or equivalent operation, then okay, maybe neighbor discovery as it is could work. However, as we have seen in these presentations today, actually neighbor discovery will represent very high overhead for these challenged LP1 setups with the characteristics that we have already seen. So this means that we need actually some optimized or some new functionality beyond what is specified in RFC 6775. And finally, with regard to header compression, well, there was also some content already introduced by Anna. So basically the idea is, okay, as we have seen, there are several possibilities that we can choose from when we consider 6LoWPAN header compression. But anyway, these end up with header sizes which are possibly too large for what we are considering here. So again, the conclusion is that probably we need some additional functionality, in this case for header compression, beyond what is already available from Lpwan. So thanks a lot.
Thank you very much. If you have a couple of quick questions to Carlos.
Eric Wing, Cisco. I mean, most of the applications we have seen are really spokes talking to the star and the cloud behind. In this case, do we really need route association, route advertisement, and all the mechanism?
Yeah, that's something we should consider. Actually, there's been discussion about this. We might up deciding that maybe we don't actually need those, and we might use some other mechanism.
Okay, thank you.
Zach Shelby, ARM. Yeah, I'm kind of on a similar thread there. I think we need to be careful in two ways, right? We shouldn't try to apply all of our IETF technology to really constrained networks. I mean, let's use some common sense. If IPv6 doesn't fit, and neither does 6LoWPAN, I don't want us creating a nano 6LoWPAN. Right? I mean, we went through a lot of work over the last 7, 8 years to go and create what we have now. So if it doesn't fit, just don't do it. Figure something else out, right? So let's not try to force. So, and likewise, if there's features that are not required from all this work we've done that involves mesh and actual multi-link subnets. By the way, you do not have a multi-link subnet here. So I'd not talk about this in this group. You have stars, they're really simple. You know, if you don't need most of 6775, leave it out. If you don't need most of 6LoWPAN, leave it out. If you don't need globally addressable source destination addresses, leave them out. Stick with 16, pre-program them. It's better than 1. You know, I think this group has to, you know, use some sanity. So I just give you some caution to not try to fit in everything. The other thing I'd comment is that a lot of what you're trying to do already is being done in 6LoW. So, you know, you need to use some sanity about the size of your working group ambition here. There's a lot of stuff. So you might want to focus on getting the basics working and then start adding some more on top.
Yeah, I basically agree with everything you said. So the idea here was to perform the analysis to say, okay, this is what exists. What happens if we try to use it? And then we maybe reach the conclusion that, okay, we have to, something else.
Okay, thanks.
Thanks.
Okay, Montenegro. Yeah, I want to echo what Zach was saying. And actually, there's examples of that approach precisely. I mean, different network layers, different FOOs, and their corresponding documents have already gone through this and say, oh, well, we don't need this part and that part, and we don't need this part of 6282 or 6775, and we will leave it out. Fine. So as you continue this work here, seeing whether it actually makes sense or not, definitely look into, you know, what is it that we might want to rescue there. Another part there is when we did the original work for 15.4, the original 6LoWPAN work for 15.4, that particular FOO, and we were doing the header compression. It was not really a stateless header compression. There was state. It's just that since by virtue of being in this network, you had already some shared state. Now it seems like here you have even more shared state because you're between not even a shared network. You have even more specific state of that node up to the spoke, up to the star. Use that. That means you can align a lot of stuff and compose an entire IPv6 packet on either side, if that makes sense, for example, without having to send stuff over the wire. So just shared state, which you already have by virtue of being on this spoke or whatever, that can be used to great benefit. My final comment was you had a slide on privacy addressing or something.
Yeah.
Okay. Could you point at it? This one, yeah. I think the privacy concerns there should be worded differently. It shouldn't be LPWAN devices should not embed their link layer, blah, blah, blah. It should be more like all devices should be mindful of privacy considerations. Luckily, we have a document in 6LoW which is precisely on that subject. So I would not say the top bullet doesn't really apply because 6LoW is leading the charge in this, right, for IoT devices. So that is one document that could benefit you guys without you having to do anything extra. You could just say, hey, that's up there. Double check it, make sure it does actually cover what you guys are concerned here. But it's a general guidance document, so I would be surprised if it doesn't apply here.
Yeah. Okay, thanks.
Suresh, can we react on the two speakers unless you're on the same subject as well?
It's on the same subject, right? So just to answer Zach, like that was like one of the things like I brought up as well. So like anything that needs to get done in 6LoW gets done here. Like so, this is not going to be a silo. So any kind of so I think Pascal used the word like solution kind of working group kind of thing. So I don't like that like kind of wording, but the idea is like the lower layer components may not happen here. They go to wherever they're supposed to go to, right? And to answer Gabriel as well, I also brought up the same point of the 6LoW privacy consideration. And the bottom line is there's like a set of questions you need to answer. The answer might be like, it doesn't apply, right? Like you don't have to necessarily like do like 7217 addresses or something like that. But one of the factors would be, I don't know if Dave is in the room, but one of the factors would be like the time of attachment that you expect it to be. And if you're going to be always in the same network, then some of the things go away. And if like the link identifier is given to you by the network, some things go away as well. So there's just a set of things you need to consider, and the answer could be it doesn't apply. So you're not going to railroad like something through people to make like privacy addresses like for everything, right? So that's kind of where the document is like trending towards, the other document. So it's like draft IETF 6LoW privacy considerations.
Hi, Vince Park again. I think my comment goes a little bit towards the issue of, again, whether these things make sense. And again, I'm not saying strongly whether they do or they don't. But it also goes to when we do the gap analysis, do we make so we identified a gap, but do we try to identify where should that be addressed? So something like if a link layer is so constrained in terms of its MTU size or packet size or the lack of fragmentation or the lack of a certain reliability driven by layer 2 acts, do you put that on the link layer? If they really want to support IP traffic or IPv6 traffic, is that on the link layer to try to address those things versus on the IP layer and above to try to address those things? And so, again, I don't necessarily have a strong opinion on that one way or the other, but I feel like maybe it's something that should be considered.
Yes, I think a number of your questions and Zach's questions have to be addressed by an architecture. We need to figure out which components go where the IP address is assigned, which device creates the final packet, which device computes the UDP checksum. I mean, maybe the model that we had in 6LoWPAN, like Zach said, is not appropriate anymore for a number of those technologies, and we have to think a slightly different topology, a slightly different model, so that we can actually get the data from the device over the internet. Doesn't mean that the device is completely conscious of IP. So we have to figure that out, and that means working together on an architecture and placing functionality here, there, and explaining what they do and how they interact. So we are not yet at the bit level, we are at the conceptual level of what goes where, how we can make that work.
Okay, just to make a point, like we're running out of time, so let's move on to the just chat discussion, cut off the discussion on this. Like I think it was very useful, Carlos, but like I think we need to move on. Like so, thanks.
Okay, thanks.
Well, maybe last question then.
Yeah, Matthias Kovac, Siemens. I wasn't sure whether this fits here or the discussion for the charter work. So what I was missing a bit was the work on what do we actually expect or what do we want from this work. So there was a lot of this gap analysis. So what can we put on this and how can we fit our stuff to these kind of networks? But not much work on what do we expect from it. And I would say it's something that we can integrate these kind of networks into the internet and use them without application level gateways in kind of our internet applications or web applications. And kind of there, the common expectation that should be recorded somewhere, that kind of all the different alliances that we saw kind of say, yeah, this is the shared goal we have.
Yeah, so just to answer you, that goes in the charter discussion. So that's where it's.
Well, application level is maybe high level, but yes, I mean, we have all seen those boxes, and that's a perfect introduction to what we want to do next.
Exactly. So we move on to the part where we actually say, okay, this is ideally the things that we. Sorry, actually. So these are the things that ideally we can take from the IETF. This is work like if we make a wish list and we see, okay, in the long term, what are the things that we could contribute to all these technologies, right? Because here today we are in the beginning of these technologies. There are millions of devices out there, but we expect to have lots of more to come. And so today we see that, okay, we can work on IP, we can work on bringing the whole protocol stack, IP, UDP, co-op to these networks. And we can, in the future, maybe work on the security, on mobility, and also work on scheduling eventually if the need is to come. The management, how do we manage the application on these devices? You know, all these are bricks technological bricks that are currently worked on at CORE or at ACE or at other working groups. So these are things that signaling, radio resource management, things that we could bring to these technologies if the need is expressed, of course. For the moment, we have everyone expressing the need to run IP UDP co-op on these networks, and we see that we have some difficulties right now to use in the current architectures, the way things are working, to put them right out. So ideally, we could do work to tie all these things together.
Which takes me to the first question for this group. I would like people to hum if they think that some of the work items that are on the previous slide actually belong to IETF, and if they think that the IETF could actually provide value to the four industries that came to us asking for help there. So please hum if you think that the IETF is relevant in that space.
Hold on. Can I suggest like a different way of doing it? Like, I just want to understand if like people in the room have a good understanding of what the problem is to be solved, like before we go on. So go ahead and ask that question first. Is the problem clear enough? Like the scope of the problem, is it clear enough for people to answer this question further? So that's the first question.
Well, you asked it?
Okay, so the question is, from all the presentations you've seen, like the drafts you've read and the charter that like Pascal and Alex put on the list, like, is it clear to people in the room like what the problem is to be solved? So now we can ask for the answer.
So you say yes, no?
Yeah.
Okay. I see what you're going, and okay, we initially had that sort of question after the charter discussion. But before even the charter discussion, we moved this question and the next question because they are more general than just the charter item. The charter item will be a lot narrower, would be a first step. But what has been discussed in this room today is more overarching what the group could be doing over the years, which includes all those elements here, like obviously IP and co-op, compression, etc., mobility over the internet, reachability, protection, security, isolation, how to schedule the devices inside this low power wide area network, how to manage the devices, how to do the radio resource management, how to manage the gateways, what kind of signaling could be used to the devices. All this list of things which kind of summarize all those ideas which have been around during this working group is a whole content that this group would be addressing over the years, but maybe not day one, right? Day one, we need to take the low profile approach, which is what the charter will be. And we have the next hour to actually discuss the charter and those questions. So we actually restructure a little bit just to ask the people if they understand that this kind of topic, whether we just want to ask if they think they belong to the IETF, basically, if they think that the IETF can help over the years, the LP1 technologies to get those things achieved.
I think it's okay to ask that question, but like first, like before, so like the reason I'm concerned is this is all in the solution space, right? The question is like, do we have a common understanding of the set of problems? Like, it's probably some subset of this, right? Like, so why are we doing this work? So I just want to understand if like the room and the people in the room and like following remotely, they understand the set of problems. Like, so there's like a lot of these things talk about like, you know, the NTU issues, like the power issues, like, right? So the question is like, do people have a good understanding of like, what are the problems that have been presented across like the different link technologies and stuff like that? So that's just trying to understand before we go further in. Like that was my point.
Okay, could we step now and ask for him? Is it?
Yeah, please.
Okay, so please, guys, if you feel you understood the kind of primes that were exposed to us today, and if you feel you understand the kind of solutions that the IETF could bring to those issues, please hum.
Opposite question. So
does
does
Yes,
anybody
the
not
no question.
understand? Yeah. So does anybody not understand the set of issues that have been presented over like the past 2 hours or and over the list and everything? So does anybody have problems understanding the set of problems that are there?
Please hum.
Okay, perfectly clear. That's good. Now go on.
So
Right.
So in the Java room is 3 positive.
I have a comment on the question you were trying
Margaret,
to
please
ask.
say your
I'm
name.
Margaret Cullen, and I work for Painless Security. I'm for running IP on everything. Okay, I'm not trying to argue, but saying, do you think the IETF can work on this big list of things? Has the problem that there are a couple of them I'm not sure we should work on. Do I vote yes or no? Okay, because I think there are plenty of them we can work on, and I don't want to vote no, but giving a whole list and saying, do you think these are problems the IETF can work on? I mean, I don't know. I'm not sure that managing devices and radios is something we can work on, honestly. I think if there's a standards
wish
body
list.
that's doing the radio stuff, they should say how we manage the devices and
This
radios.
is a wish list, and then we'll go charter, and we'll have this exact discussion about those charter items. Can we take those ones? Right? The charter items, this
But I
is a global
certainly
wish
think
list.
we can work on compression and fragmentation, for instance, right?
Okay,
I mean, so my answer would be mixed. So I was trying to understand how I would answer your question if my answer to this is yes, these, no, those.
Okay, the questions like, do those kind of features generally belong to the IETF? Do you understand what is needed by those technologies? And then we'll figure out the match of what we do out of all this wish list.
What if my answer is some of these things do belong to the IETF and some of them do not? Do I say yes, no, both, neither?
If there are, I would say,
So restriction. So that's why, Pascal, I didn't want this question, right? Let's go in this order. So people understand the problem. Let's go to the charter. I think we should come back to this at some point.
Yeah.
Just go back to the charter that you posted, and then we discuss what's in the charter.
Okay. So that's exactly what's next.
Okay.
Yeah. Yes.
To this one.
So,
Okay. Just sorry, just one quick point before we move to the charter, because I think there could be confusion on people, and some of us we've been having discussions and we have a clear idea, but I can see that for some people it's not clear exactly what we're trying to do here. The list of issues that we discuss is not necessarily what's going to map to the charter. We might find out that some issues can be solved in different groups, like 6LoW, 6TiSCH, or not in IETF. So the first thing is understand if we want those items in IETF, and I want to highlight that, and then a subset of that may make it into the charter. So just want to clarify that is what we want to do here. Okay.
And so to address that, we did not want to basically boil the ocean and say we'll address all those items in the wish list. So the way we propose a charter is stepwise. Take maybe the low-hanging fruit first, and as Margaret said, the low-hanging fruit is probably has to do with the compression of IPv6, UDP, co-op, this sort of thing. And actually, we've got work which has started and which shows that we have feasibility for doing those things. So we chartered around that. We chartered around the understanding this technology, getting feedback from those technologies about what needs to be done, and providing a first set of solutions to show them that we are useful. And this first run of technologies is effectively around compression and not reinventing fully the wheel, but probably making the best of what exists today from 6LoW and from ROC, which were presented to us. That's exactly what the work is happening in the mailing list. So the stepwise charter is what we're going to discuss now. Another thing about being here together is we have a lot of people in this community which are not used to the IETF, and having a place for them to express their needs and from that place go to the other working groups has been very, very useful and efficient for the 6TiSCH work. And we see that this community coming now to the IETF, this new community, would really appreciate to have this place where they can talk, get agreement, and then get things done from the other groups. Right, so part of the value of working together here.
I think it's good, Pascal, but we really need to go look at the charter.
Okay, so this is the next slide. So we can.
So,
go-
have people had a chance to read the charter on the mailing list? How many people follow the mailing list here? Perfect, thank you. Go ahead.
Okay. So for the note takers, everyone in the room almost. So we go step by step on the items that we find in the charter. And the first one is produce an informational document describing and relating some selected LPWAN technologies.
So one way we can do things is I can bring up an editor and maybe if we agree on modification, we can do that. For the time being, we have slides where we just wrote down the charter, the proposed chartered item. The first one being this competitive analysis. So can people just read that and comment? And if needed, I'll take my editor out.
Okay, so the goal of this is to go through the list, figure out if there's any areas of lack of clarity, and figure out if there's things that are missing or things that are there that shouldn't be there. Okay, that's the goal. So concentrate on those things when you come and talk. Thanks.
So basically, this document would be the summary, the IETF draft for the 4 presentation that we got. Something so that people from the IETF who are newcomers to LP1, they could read and they would understand what we are talking about. Does that make sense to include this work in the charter? It would be an informational.
I mean, I don't object to this work. I mean, can we just go through maybe the whole charter and then talk about it?
There are 4
or-
items like this, so
Okay.
4 slides later we're through.
Yeah. So we go through all of them, and at the end we ask the 4 questions.
Okay. So second charter item would be the best practice.
Hey, Renzo relying for Pat Kinney, was like 5 minutes ago. IEEE 802.15.12 is considering working on device and rider resource management for 802.15.4.
Yes, I mean, Bob mentioned 1512 earlier.
I think he was just repeating Juan Carlos' point where he said there's other SDOs who may do work for their own radios, like the same point like Margaret also made. Pascal, one-line summary again, go for it, of this, like you did for the last one.
So this is basically Anna's document, what Anna's proposed to us. So Anna proposed the work coming from. I'm sorry. So this would be turning Anna's work into a work group work where all the parties agree on what the gap analysis would be.
Per technology, gap analysis?
No, the idea is not to finger point.
Alper said, is it going to be per technology?
Yes, and the answer is hopefully not. We want to give, but that can be discussed by the working group because that would be a working group document. My vision is that we would not finger point if we can avoid that.
Yes, I agree with this. Alper again, I agree with that. But at the end of the day, we need to understand among all these 4 or 5 different things we're going to do here, who would be the customers to those? Because I mean, that's what IETF needs, right? If we're going to do something, we need to make sure someone's going to use that, and we're going to make sure there's a need for that. And I think per technology, the answers would be different. So it would be good to understand who needs which one of those 4 or 5 things at some point early on.
Looks fair. So when we build this document, let's discuss that. But the overall idea is exactly that. I mean, showing that we are developing this technology because there is this need in one of those 4 people, 2 or 4. More of them.
So Pascal, that would be like a small text change. Just make a note of it, and we'll go on to that after. It's going to be a small text change. It says there might be things in this document which are technology specific or not. That's it.
Okay. Do we want to do that now?
No, just make a note. Alex is making a note. We just move on.
I made a note on this. Okay, next.
Okay. So this may be more than 1 document because the way it has started, it shows that it could be 5 documents actually. So we realized that the existing ROC and 6-loop compression are not designed for the ultra strict requirements that we have here. And work has started to actually evolve like a conjunction of what is done in those 2 compression mechanisms to make the best of them all. and use the distribution of context like 6LoWPAN has, and very strong context with a lot of information in it like ROC has, to get a very, very good compression, better than what we achieve with 6LoWPAN, in the order of what ROC can do, but without the overhead of learning that ROC has. So the way the work has started in this area is that there is a generic compression which is independent of one of those 4 technologies, but because some bytes have to be taken from the MAC layer or some limited application layer space which would be there for us to use, probably the way it's being used exactly will be technology dependent. So there would be this overarching document which explains how this new ROC technology, and then there would be per application or even per technology documents which say exactly how it's being used in this particular case. So the cool thing with this is the work is actually well advanced, and it shows that we can actually achieve this. Any comment on this one?
Yeah, okay, there's one more after this. Samita, go ahead. Yeah, go, gentlemen. Zach, on 3.
Zach Shelby. So we went from let's apply 6LoWPAN that we know well to these things to let's invent.
We didn't say let's apply 6LoWPAN we know well.
All right.
No.
Well, okay. Well, I was hearing that like let's do IPv6 over these things, but now what I see here is let's go invent a new method for compression over multiple layers in our stack.
Well, yes, the second is true.
Why?
Because what we said earlier, that 6LoWPAN won't give us the compression level we want, and ROC will do it, but as a learning phase, which is too expensive. So we want the compression that ROC can do, and that NB-IoT is already using, and we don't want the overhead of the learning phase that ROC has, but we want to reuse the kind of ideas that 6LoWPAN, the compression has, that we can distribute the context over a protocol. So the best of both worlds in those discussions we had was, oh, let's learn the way 6LoWPAN learns, but let's compress the way ROC compresses, which is a lot more efficient than 6LoWPAN. I mean, ROC can put things back in 1 byte, basically, once everything's stable. And that's really good. And that's because we have more things in the context. 6LoWPAN just have prefixes basically in the context, but see all those other fields that you could actually, which are for instance constant, and that you could put in this context. So it's kind of an evolution of 6LoWPAN and ROC
Yeah, and I think that might be, I think you might be getting on to maybe a better way to explain this, because this kind of opens the door for us maybe doing a whole bunch of work we don't need to do. Yeah, there might need to be some extension. I mean, 6LoWPAN already elides IPv6 and UDP, most of UDP.
Yep.
That's what it's all about, right? Yes. So you might really talk about, extending the way and the amount of things we can elide, because as Gabriel said earlier, right, now we have more context to work with.
Yes, that's a way of saying it.
We're not really inventing a completely new.
Well, we are not inventing much because we are rebreeding 6LoWPAN and ROC, but all the formal language of ROC is already there. It's breeding 6LoWPAN and ROC, really.
Okay, move on.
So I guess, Pascal, I'm just trying to understand, what does it mean by over LPWA? I mean, we already asked, the question was asked a couple of times, are we talking about an end LoRa device talking to its gateway and sending IP packets, or a Sigfox device, or, I mean, we already know NB-IoT, it's got a gazillion bytes, it can do that anyway. So I'm trying to understand, what does over LPWA mean so that I can at some point vote?
Yes, and we, at the BOF, the non-workgroup following BOF, we looked at 2 models. One of them, the device has some conscience of IP. It could, in memory, generate an IP packet that it will compress. It could compute an UDP checksum. Now, there is another model where you emulate something like a PC with some USB dongles, and the USB dongle is really something on a port, right? So you talk IP to the PC, and then from the port number, you send all those bytes to the dongle. And maybe you can
Which drives to the architecture design, not
I think we need to serve both cases, if you ask me. Right?
Okay.
But we have to agree on that in the architecture. Now, something like this compression model can really do both. We have to agree maybe per technology how it's going to be used. Maybe some technologies will want the devices to be IP aware, fully IP aware. In some cases, you want the device to be IP dump, and the real stack is in the gateway.
Yeah, I'm just picking on words. I mean, I sort of feel like this should be, you know, IPv6 packet inside and over an LPWA.
We won't force that. I mean, I don't want to force that. Maybe some people will,
Right.
over the course of this work, will force that.
You know me, I'd love to see IP at the very edge of the network. That's all we've been talking about for a gazillion years. I just wanted to understand what
I certainly want this to be enabled. I don't want it to be the only thing we
Forced.
support.
Okay.
But enabling, yes, definitely.
Okay, so maybe we review the next one, and this is the last
Yes.
part of the charter.
The last one was the fragmentation, because that came from the groups. Actually, they come to us and said fragmentation could be good. We have a beginning of a story for fragmentation. That's really a beginning. So, but that's an ask, actually, a real ask we got. Just like IP Co-op, we got this ask. Because we get the ask, we look at it. Margaret?
It's Margaret Cullen again. I have kind of two big questions about the charter. One is that I can't say I've been on the mailing list. I've looked back at the archives. And I haven't looked at all of them, right? So I may be missing this, but is it very well defined exactly which LPWA technologies we are talking about? I've heard 2, I've heard 4. I think I saw 4 presented today, but I'm not positive.
In the charter, you're seeing just the work items here. So if we review the whole charter, yes, we've listed 4. The 4 which presented today.
Okay.
Because we made that poll, we asked who wants, and those 4 came to us and said, yes.
Okay, no, I had heard 2 earlier at some point, and then there seemed to be 4, and I just want to make sure I understood what we were talking about. And the other one is, I mean, the ultimate goal here has to be IP over foo documents, right? Where do they come from? Like, we're writing all these little elements that the IP over foo documents would reference, but I don't see any IP over foo documents, and I'm kind of confused by that, because like, I might like to do one technology at a time and do IP over foo and then reuse, like, break out anything that's reusable, and then on the next one reuse it if we can, right? Like, because that's how I think, right? I mean, I was involved in IP over everything, digital vertical blanking interval. You know, I mean, we've done IP over lots of stuff. Why are we doing this in a different way than we normally do, which would be to go, here's a technology, let's get IP over it.
So, Suresh Krishnan, so like, just to answer you, Margaret, like IPv6 over foo, like for some definition of foo, belongs in 6LoW. Okay? No. So there's like a set of things that are more than IP over foo that need to get done. So the goal of this thing, right, like the LP1 stuff, is to figure out like what more than that needs to get done for a really constrained technology. So if we say like, if it's just IP over foo, it's going to go in 6LoW. Okay, so is there like something that more that needs to get done so that links with, like, say, severely constrained MTUs can work, right? Because if you just define IPv6 over something, we might end up with like, let's say like we say like, oh, we're going to run arrays on a link, okay? There's like one link, the Sigfox link, right? We get like 4 messages a day of like something like that, right? Or 10 messages a day, something like that, of like 4 bytes each, or something like that, right? Some random number, small numbers, right? So, you know, an array is going to take like a month to get through, right? Like, so like doing like a IP over foo is not sufficient, right? Like, and so that's kind of the point to figure out if there's something more than IP over foo. IP over foo is not going to be done here.
I mean, if you look at ZigBee IP, they spent a lot of energy putting together IETF components to get a solution that works, right? That's right. Maybe solution work group is not a very good term, but what we want to do is look at a number of components which come from the IETF so that we can deliver a package of components to those guys who don't have as much experience of all those components as we do, who are looking at the IETF like the place where there are almost 8,000 RFCs, and they just don't know what to do with them.
Okay.
I mean,
you guys are giving me different answers, all right? You're saying we're going to give components to some other group. All right. He's saying we're going to give components to 6LoW. who is then going to write IP over foo documents. Like there's going to be an IP over name of low power WAN, what was the Sigfox? So, so there'd be an IP over Sigfox that's going to reference stuff written by this group, but be written in 6LoWPAN. Is that what you're picturing?
We'll figure that out.
We had to figure that out, right? So, but the point is, Margaret, it's not going to be in this group, like no matter what. So it's either going to be done by, for example, 3GPP already has a definition of like V6 over something, right? They're not going to come to IETF at all. But in either of the cases, whether like, for the higher layers, yes. Okay. So the point is like, it's not going to be done in this group. So it's not like a work item here. Whether it's done in 6LoW or in the IETF is a completely different question. And we don't want to answer that here.
Yes, what we'll be providing with this work item is a new compression mechanism, which is an evolution of ROC. And ROC working group does not exist. We won't form a ROC working group just for that. So because we are meeting all those people in this place, we propose that as the first work item that we'll be doing together. But as I showed, we'll be looking at overlays, we'll be looking at AAA security, a number of things, so that we can provide the IETF components that those guys need.
Okay. I just want to make a point. We cut the mic line at Eric because I want to ask a few questions before we go.
Okay. Hi, Samita Chakrabarti. Just some general comments from today's discussions. I think the charter right now is based on some of the drafts that was discussed in this group and today at the meeting. But in my mind, when you are talking about a new kind of requirements on 4 different LPWAN technologies, I would like to see the new requirements that are not addressed today at IETF. So I think that is what your goal is, to add something new that is not addressed there for your requirements. So if your charter first handles the requirements, issues, and gaps, yeah. So I think that would be the first step, and then we can discuss how that can be addressed, right?
Well, we started like this. We can't just do requirements. I mean, the work group needs to produce something which is usable. Yeah. And those guys won't wait 10 years when we go through requirements to start doing some work. So this is why we have at least this one work item which is producing something, right?
Yeah,
it's not a big thing, but at least we deliver something. But the first 2 work items are really along the lines that you're asking. Those 2. Right, but at least we produce something. This ROC 6LoWPAN compression interbreed, that is really what is needed in that space.
Yeah, so I think from my point of view, I would be more interested on the requirements issues, and then some ideas what are the things you want to do.
We'll do it, right? This is this charter, I think.
So Pascal, we talked about a few other topics, right? Essentially, like signaling between the gateway and the radio termination point and the anchor or aggregation gateway. So those kind of work items, when will they get in? Like I understand the focus all around compression. This is great, but I'm trying to see what is the logic behind this prioritization? I want IPv6, sure, great, absolutely.
We'll have to sort that on the mailing list, Sri, because I don't have an answer for you right now. We have a very long wish list. People have not fully agreed that this belongs to the IETF. RRM was part of that. We have written it down, but we have to sort that on the mailing list. We are below time, right? Time is passed already. We have not asked the questions. So it's really time for us to ask the questions. Suraj. I'm sorry, Sri, but we can't continue.
Hold on.
This.
So one thing I want to do is make sure we have a basic understanding of the charter. Like work items, we can probably discuss further on the list. Okay, but I want to have a feeling whether we have something to go for a working group or not. Okay. So the first question I want to ask is how many people understand what the charter means as it's written today? So do you have any issues understanding the charter as it's written today? Anybody who has questions, please hum. Okay, good. Okay, so how many people think there's enough work for IETF to do here to form a working group? So people who think yes, please hum now. Okay. So people who think there's not enough work here, or it's unclear if there's enough work here to form a working group, please hum. Okay, who are hum, can you please come up and say what's unclear?
So I don't think you asked the question to form a new working group, and that's not clear to me. I think there's interesting work to be done here, right, that belongs in the IETF. To form a new working group, right? Not to form an existing working group, because we don't form existing ones. So there is work to be done here, and it belongs in the IETF. But where it lands, separate question.
I mean, there's one work item, right? Is that what I understood? Well, there's a couple of infos and one, and we're to call it the.
At least one.
We're to call, but again, it seems to me we have this scope for working group and this much work. So is there enough work to form a working group? Yes, an extreme compression working group. I don't know.
So I came up to the mic earlier to say there's one missing as well, because these devices need IP addresses and default routers. And if neighbor discovery doesn't work, right, well, then we at least need to have some provisioning protocol that does that provisioning up front, right? So it's one of those two, but I think that that's something that needs to be worked on, whether it's neighbor discovery tuned again with infinite lifetimes or something else, right? A Yang model, a co-op, admin, whatever they're called. But.
Right, thanks, Eric. So the point is like not to like work with charter on this like mic time, right? But we can certainly add deliverables, Eric, if that's something that's missing, right? So we're going to continue working on the list, but the idea is to figure out like if there's enough interest in here. So I have follow-up questions. How many people here are interested in contributing either drafts, contents to drafts, or like implementation stuff here? Hum, please hum. Okay, thank you. How many people are interested in reviewing documents that come out of this group? Not yours, but stuff other people do. Okay. How many people here from other SDOs who are potentially thinking about this are interested in using the output of this working group if something comes out? Please hum. Okay, thank you. Leonard, go ahead.
Yeah, thank you. It's where it will be required to clarify exactly what you would like to do in this working group, because for instance, for compression, I think that there is a lot of support, but for instance, nothing will be done for security, especially for other SEO, because they will have their own solution. So I think the compression is one goal. The other one will be to see exactly what it is needed to be done within IETF, and that could be used by others, because if we're doing something that it will not be relevant for others, I think it would be useless.
Right, makes sense, Lionel. Okay, so I got the answers that I wanted, like from this meeting, and we can continue discussing the charter and milestones on the list, right? Like, but I have a feeling that there's like enough to go about doing a working group, or at least try to form one, and once we iron down the charter. So thank you very much for coming, and enjoy your meeting. Thanks.
Everybody cite the blue sheets. Blue sheets, everyone.
We're the secretariat. So any of the registration people can take care of it. Thank you.